ferns, and fish, bears, and butterflies, petunias, and prairie dogs. The variety of life with which we share this earth is truly amazing. But as different as living things can be, they all share one thing in common. They all need certain life-giving chemicals to survive. One of the most important of these is nitrogen. And today, we'll see how living things get the nitrogen they need and how it's recycled through nature. All living things, be they birds, a mushroom on a rotting log, gators on the prowl, or any other organism, must have nitrogen. Without it, they can't make the amino acids, proteins, and other compounds they must have. Most plants absorb the nitrogen they need from the soil or water in which they grow. Animals, in turn, get the nitrogen they need by eating plants, or in the case of meat eaters, by eating animals that feed on plants. But no matter how organisms get their nitrogen, the fact remains, without it, they die. Obviously, then, it's vital that nature doesn't run out of nitrogen. And at first glance, it wouldn't seem there's much chance of that. That's because nitrogen makes up more than 3/4 of the air around us. And with the atmosphere that rich in nitrogen, you would think that there would be more than enough to go around. That's not the case, however, because the nitrogen in the air around us is the wrong kind. And that's because most plants can't use nitrogen in the pure gas form in which it occurs in the atmosphere. Instead, they need nitrogen that's been fixed or combined with other elements into compounds. Fortunately, nature has several ways of doing this. Lightning is one of them. It causes nitrogen and oxygen atoms in the air to combine. The resulting nitrogen compound then mixes with rain and falls to the earth, where it undergoes chemical changes that make it easier for plants to absorb the nitrogen it contains. Such lightning-powered fixation provides large amounts of nitrogen for plants. However, far more is fixed in the soil, a fact farmers have long taken advantage of by rotating crops, such as corn, that quickly use up soil nitrogen, with soybeans, peas, clover, and alfalfa. Such plants are called legumes. Legumes act as natural fertilizer factories, and they pump large amounts of nitrogen back into the soil. And here we see the small pea-shaped nodules that grow on the roots of soybeans and other legumes. These nodules are at the heart of the legume's amazing natural fertilization process. They're caused by bacteria, such as the ones we see here, magnified millions of times in this cross-section of a soybean nodule. These bacteria fix or change nitrogen into a form plants can use, and they live in a symbiotic or mutually beneficial relationship with legumes. As they're part of the bargain, the host legumes supply the carbohydrates the bacteria use as food. In return, the bacteria convert or fix nitrogen gas in the soil into compounds the host legumes can use. This process often produces surplus nitrogen that's released into the soil, thus fertilizing it. As important, however, as the bacteria are that live with soybeans and other legumes, they're not the only microbes that fix nitrogen. The soil also is home to free-living nitrogen-fixing bacteria. Like those living with legumes, these microbes also fix nitrogen. Once nitrogen has been fixed in one way or the other, plants, such as grass, can then absorb it and make it part of their own tissues. When animals eat these plants, some of the nitrogen in them is used by the animals to synthesize or make their own tissues. So far today, we've seen how lightning and bacteria fix nitrogen atoms into compounds that can be used by plants and made part of their tissues, and those of the animals that eat them. This binding of nitrogen atoms into living plant and animal tissues is the synthesis or building up part of the nitrogen cycle. In addition, the nitrogen cycle also has a downside. This, the decay or breaking down side of the cycle, takes place when dead organisms, manure, and other such wastes decay, and in the process free nitrogen compounds from their rotting tissues, thus making them available for use by a new generation of living things. Not all the nitrogen compounds freed by decay are reused immediately, however. Instead, some are acted upon by various so-called denitrifying bacteria. These bacteria get energy from decaying tissues, and in so doing, they convert some of the nitrogen in the rotting tissues into free nitrogen gas. This gas is released back into the environment where it's free to begin the cycle all over again. Earlier, we saw how farmers benefit from nature's nitrogen cycle by planting soybeans and other legumes, such as clover, to restore nitrogen to their fields. Farmers also become involved in the nitrogen cycle when they use artificial fertilizers. Many modern high-yield crops need the extra nitrogen such fertilizers provide. Unfortunately, however, their use is not problem-free. In many areas, water supplies have been seriously polluted by nitrogen. For example, the water in some areas is so loaded with nitrogen that it's hazardous to drink. Experts think that nitrogen fertilizers cause much of this pollution when they seep down through the soil into the underground water supply. Even large waterways, such as the Chesapeake Bay, America's largest estuary, are being polluted by nitrogen. In the bay's case, most of the problem comes from nitrogen-rich fertilizers and the millions of tons of manure and the nitrogen it contains that good old Bossy and her likes produce. These nitrogen-rich pollutants wash off farms and into the many streams and rivers that run into the bay. This excess nitrogen can cause water plants to grow so fast that conditions develop which rob the water of its dissolved oxygen, suffocating fish and other organisms in the process. But today's modern farming techniques and the huge amounts of fertilizer and the manure-producing animals that so often are a part of it isn't the only human activity that's upsetting the nitrogen cycle. The exhaust from our fossil-fueled powered vehicles and the emissions from our electric generating plants also add large amounts of nitrogen to the environment. And when water in the atmosphere combines with this nitrogen pollution, it often returns to Earth as the acid rain, snow, or other precipitation that's helping to ravage so many of the world's woodlands. Acid precipitation is also making many of our waterways so acid that a large number of aquatic species, many of which are of great commercial importance, are being seriously harmed. As we've seen today, nitrogen is vital to all life. Without it, there could be no plants, animals, or other organisms, no life at all. Fortunately, the natural recycling process we call the nitrogen cycle assures that we and all other living things get all we need. The following questions will help you to find out how much you remember about the nitrogen cycle. The directions are simple. Mark the boxes on your answer sheet either true or false, or fill in the blank with the correct answer when you hear this tone. Okay, now here's the first question. True or false? Nitrogen makes up about 50% of the air around us. Okay, here's another. True or false? Both corn and soybeans are legumes. Here's a fill-in-the-blank question. Some of our waterways are being harmed by agricultural nitrogen pollution from manure and true or false? Most plants absorb the nitrogen they need from the soil or water in which they grow. Here's another true or false. The nodules that grow on legumes' roots are home to symbiotic bacteria. Here's another fill-in-the-blank. Meat eaters get the nitrogen they need by eating animals that feed on All right, here's another question. True or false? Most of the nitrogen that plants use is fixed by lightning. The nitrogen in vehicle exhausts and power plant emissions contributes to Here's another. Most plants can only use nitrogen that has been combined with other elements, or And here's the final question. True or false? When organisms rot or decay, they free or release nitrogen atoms that can then be used by the next generation of living things.